What's up, Chad?
What's good, guys?
Hey,
We
can
are
you guys
now
hear me okay?
now being recorded.
It's 10 o'clock.
Yes. Can you guys hear me okay?
Yep.
I can hear you perfectly, Chad. You're coming in crystal clear.
We can hear you, Chad Hansen.
Chad Hansen. So formal.
There we are.
All right. So I see Kaizek. I see Hayden. I see Hans. Hadden. Sorry.
All good. Everyone calls me that when they first meet me. It's not that big of a deal.
Sorry about that. And
All good.
Isaac. So why don't we do we want to make is Axel, is Axel and well, who else do we have join in here? Do we need to wait, or because Axel's going to be helping you, Isaac, today, right?
I think so, yeah.
Okay. And he's joining. He doesn't have something else going on today.
I think he's pulling up. I haven't heard any indication otherwise.
Okay. Why don't we give him a few minutes then?
I'm just gonna log in on a different virtual machine here.
Sounds good. And we do have is the recording going?
Yes, it's going. I'm gonna go ahead.
Calls me record. Perfect.
All right, there we go. And GIMP is coming through. Perfect.
Yes, we can see your screen.
Splendid. I was concerned it was going to give me crap, but it looks like it's going to work. All right, I'm going to switch over to a different desktop here.
Oh, there's the full screen button.
All right, perfect. There we go. We are ready to rock and roll with my rudimentary whiteboard. Let's go.
Sounds good. So before you get started, you want to just kind of give just a brief overview of what you're going to cover today, just to recap, so folks understand what we're covering. Yeah.
So the big thing I want to cover today is more of like, what is Linux? Because I'm kind of picking up that there's not, especially because do we know if Naomi's going to be joining? I just realized she's not here.
I am not sure. I tried to make sure I got it out there. Just a reminder that it is virtual. I'm hoping everybody saw that and nobody showed up at Nubo today.
Let me see here.
See, what, 7 folks on the call, right?
Mm-hmm. Oh, she's out of town.
Yeah. Okay.
Okay. So yeah, I guess she won't be. So I guess this is mainly this. The big thing I want to talk about today, though, is like what is a hypervisor and kind of going more into the low levels of networking, more of that, kind of like that. But more importantly, like what a hypervisor is, what is a virtual machine, why they're important, and why we use them like crutches for everything. Because everything we're going to be doing in the competition is going to be using a virtual machine. Everything's going to be in a VM. It's pivotal that you know what a VM is. So I'm going to use a bit of an analogy here to kind of explain what a VM is. So let's say I have a farm here. I have some farmland here. I got a barn over here. And then I have my little foreman. This is our farmer here, okay? So in our little graphic here, we can think of this as an analogy of our computer. Our computer, our farmland's our RAM, our barn is our storage, and our farmer here, well, he has all of his little farm hands. We'll say he has 4. Those are our CPUs, exactly. And we can think of our farmer as our operating system here. That's our OS. So this is all fine and dandy. We have these guys, they're doing some work on the farmland here, and they're doing what they need to do. But let's say we have a binary here. Like, let's say we have some exe. We have an executable here, and this is a malicious one. This is a malicious executable. It has some bad code in it. It's going to try to steal our information. So this is not very good. We don't ever want to run this, because what happens is let's say we try to go put this on our farmland. Well, we can think of running bad code as similar of like putting weed seeds in your farmland. It makes it all bad. It ruins everything because now we have weeds everywhere. And now our farmland is all bad, and now it's basically useless. We have to rebuild everything. It's a really bad time. So we have a couple options for preventing that from happening. One thing that we can do that a lot of companies do is we have all this land. We have all this land and we have all these farmers here. So let's say what happens if we build another farm on top of our farm? And inside of each of these farms, they're going to have their own farmhand and their own barn. And we'll go ahead and we'll take some of our guys and we'll allocate them into here. Well, now what happens when we put a bad executable in here? That executable, when it's running inside that VM, will only destroy this farm. But the rest of our farm, the rest of our farmland is perfectly safe from what happened in here. Does that kind of make sense?
Yeah. So how does it work though? How do they do that?
Well, that is where our hypervisor comes in. So we'll go ahead and I'm going to create a brand new canvas. So a hypervisor is how we make it happen. There are two types of hypervisors. We'll talk about the most common one that you'll work with, which is a type 2 hypervisor. Just know that there's multiple types. I can explain that further if there's interest, but just know that what we're going to be talking about is a type 2, where basically we had our OS here. Our OS, he controls everything. So he has our RAM under his control. He has the disk under his control and all these fine things. But we want to run virtual machines with him. So what he does is he's like, okay, I'm going to package these into a cute little box. And I'm going to hire a new guy here. And he's going to be called Mr. Hypervisor. We'll just call him Mr. Hyper because that's kind of a cool name. I'm going to be honest. So what OS over here does is he's like, okay, you can have some memory and some disk. And what Mr. Hypervisor does is he takes this RAM and creates a virtual box of this information containing his own little RAM image and his own little disk image that is separated from our operating system here. So he keeps it all separate and he isolates it from our operating system over here, creating, in the most literal sense, like a virtual computer. It is literally like running a laptop on your desktop. It's kind of cool. So it creates this isolation.
The use of it is to stop malware from destroying your entire PC.
It's designed to prevent, yes, it's designed to isolate things. So like, let's say, we'll use another example, one that's like more applicable, but that's exactly one reason. But let's say I have a web server here. Let's say I'm running Reddit, right? I have a Reddit and Reddit uses a web server. So we have our web server here. And I have some clients over here. Happy was our client. So I can't draw on a mouse. So Happy is going to try to contact the web server here and get some Reddit because Reddit is a very nice service that's very wholesome and pleasant to interact with. But let's say over here, we have Jim. Now, Jim doesn't like Reddit. Jim thinks Reddit is a horrible place to be. So what Jim does is he sends a special sequence of data, just like a malformed request, to the web server that Reddit runs. And because of bad code running on the web server, just poor code that wasn't caught, it causes the server to crash. So now Happy's sad. He's no longer called Happy, he's called sad because he can't get to Reddit anymore. an approach with virtual machines, and this is where it gets kind of cool. Reddit can have multiple web servers all running on the same computer. And then we have another piece of code here that commands it. So now when Happy over here makes a request, he's still going to get Reddit, because Jim over here, he's trying to crash the servers too, but he can't crash them because there's always one more that's still running, because even though he crashed this web server and this web server, because he's running in a separate VM, he's protected. What's up, Chad? You raised your hand.
Oh, sorry. Yeah, I was on mute. Should we talk about too, like this is one reason for hypervisors, right? Is the security implementation, but we might want to talk a little bit, or what are your thoughts on talking about how this also allows us to better scale hardware, right? So.
Oh yeah. Yeah. Being able to scale. Yeah,
Yep.
we can definitely talk about that. So this is where I'm glad Chad brought that up. We can cover that next. So let's say we have a desktop, right? I have a desktop. I have a whopping 256 gigabytes of RAM in this sucker. I spared no expense. I got like a 64 core Threadripper on here. I got 64 CPUs, all of these things. But I only have one OS running on there. Well, that's not very nice, because I don't want to have my web server have all 256 gigabytes of memory. That makes no sense. It makes absolutely no sense. But what does make sense is if we use our hypervisor. This is where Mr. Hyper comes back into play. Mr. Hyper. He comes into play and allows us to spawn. Let's say we have a Windows virtual machine here for, let's just say, general usage, like maintaining the system. And then we have some web servers here. And then let's say we have like a file server so we can store all of our funny cat videos that we watch on the internet. Because we have all of these resources on a single computer, we can run all 5 of these computers on a single computer. And in the event, if some servers crash, because of the way hypervisors can be configured, you can have it set up to just respawn those VMs. So if they crash, you can just bring them right back up automatically, giving us very fine-grained control over what's happening on our computer, allowing us to spawn VMs of different operating systems. For example, if you're running Linux, you can use a hypervisor to run a Windows computer on your machine. So you can use Windows on Linux, or you can do it the other way around. If you have a Windows computer, you can run a Linux virtual machine to do Linux things. Mac OS has the same thing. You can run Linux and Windows VMs respectively on Mac OS. It's a very versatile function.
Is it hard to do that?
No, it's not. It really isn't. I mean, let me think here. I don't have a way to demonstrate it because I can't get into Ice Age right now, and Oxel isn't here yet. But with like setting up a hypervisor, setting up hypervisors can be difficult, but that is not necessarily in the scope of what we're dealing with in our competition. You won't need to deal with setting up the hypervisor. That's all taken care of for you. With installing a virtual machine, that's very easy. Oxel will walk us through once he gets here, because I think he has access to Ice Age, and he can help us get into access there.
Will he be telling us how to do it, or will we have to do it?
He'll walk us through it, and then we'll see about getting you guys set up with Ice Age, because I don't know if it's up or not. I was having issues with it earlier last week. I couldn't get it to work. But we'll walk you guys through it, and then we'll try to get you guys installing a Linux VM, so then you can play around with that and just kind of mess around with Linux. So then
That's not like a risk
sandbox.
to our computer, though, is it?
No, there's no risk. It's all happening in the cloud, aka someone else's computer. So if something goes wrong, just push the reset button, and you're back to ground zero.
Like FN plus Alt 4.
A little more complicated than that, but in the same essence, yes. You could just terminate it and no harm will come upon your computer.
Nice.
Yeah. Oh, let me think here. Kind of a quick presentation in terms, I guess we do have time while we're waiting for Oxel. Networking. So, you guys remember our little chat about networking last week?
Yeah.
So VMs are weird. You may have noticed when I was talking about Mr. Hypervisor here, I didn't mention anything about networking. And that was kind of intentional because the hypervisor doesn't handle networking. Not all the time. Some do, but it's usually very low level. So it's weird in the regard that we have, let's say we have 3 computers, right? We're running 3 computers, and then I have 1 computer they're all running on. But I only have 1 internet connection. Well, we have a little bit of an interesting issue here because I have 4 operating systems here that would all like to use the internet. So how do we solve this issue? Because we have 1 internet connection, but we need 4 computers to use that 1 internet connection. So there's a couple of approaches. The most common approach is using a virtual internet connection. So I have a little internet connection there. He has his own internet connection. And then he has his own internet connection. And instead of these guys having real internet connections, all they do is they just route what's called routing. We may get in a TCP IP later. I don't know. But what they do is they literally just go through here and then they look like they came from our operating system here through a cool technology called NAT, which they'll spare you the details of what it is because I barely understand how it works, but it's a magical piece of software that allows us to say, oh, this isn't a guest operating system making traffic. No, this is my operating system making these web requests. So then everything works as if there is no sharing of the internet connection. All of these guys can visit, he can go and visit Reddit while he is like updating, he's doing updates. And then this guy could just not have internet. We can cut him from internet. Say we're like examining malware. Like we want to experiment with malware in there, we can just cut him from the internet and now we're perfectly fine. Yeah, so that's kind of like the lowdown of hypervisors and what we'll be dealing with virtual machines. Chad, did I forget anything? Is there any pressing things with VMs that I have not touched on yet?
No, I think you did a great job. I mean, it's kind of, the biggest thing, there's other reasons too, but the big thing that Isaac touched upon is security segmentation, right?
Mm-hmm.
And then also, like for big corporations or even for what we're doing, is better use of that hardware. So like Isaac talked about, you can take a server. See, in the old days before hypervisors, in data centers, you had to have, it was a 1-to-1 ratio, right? So if I wanted to set up a web server, I had to have a physical server, and there was just one operating system running on that physical server. So part of the challenges when you look at data centers is, with that, it doesn't scale very well, right? So if I have to set up a physical box for every single server I need to set up, well, I've got to run a lot of power, I got to run a lot of network, and I need a lot of space in my data center, which equals dollars, exactly, right? And so part of this is you get what's called a better density of and utilization of that hardware, because now you're taking that same physical hardware and you're better utilizing the CPU cycles because you're sharing it between VMs. So maybe talk about that a little bit, how that
sharing of resources.
Yeah. Yep.
Okay. Yeah. Yeah, we could talk about that here. I was kind of hastily drawing a diagram to kind of show what you were saying. So I kind of touched on it earlier with over here. No, cancel. Don't delete that. Not my beautiful drawings. No. I kind of touched on it over here, but the big thing when it comes with hypervisors is that we have our hypervisor here. And let's say we give our hypervisor 8 gigabytes of memory. And in the regard of at least type 2, this is really, we'll just stick with type 2 because they're much simpler by design. That 8 gigabytes comes from the operating system. So we have an operating system with 8 gigs of memory. Whenever we create a VM, when we allocate memory, it's the same way we allocate memory for a program. So what we do is that we just say, oh, we're just going to use 6 gigabytes of memory, and then we're going to tell our hypervisor friend over here, let's bring back Mr. Hyper. We're going to tell Mr. Hyper that we want a VM that has 2 gigs of RAM. And what he's going to do is he's going to literally use the same syscall that any other program would call. What syscall is basically just a special piece of code that allows us to talk to the operating system. The same syscall for allocating memory. So in our case, we're going to get 2 gigs of memory. And we're going to allocate that to our VM over here. So the way that in particular with hypervisors are weird is the regard that, let's say our OS here, we have an OS and it's running Linux, and Linux isn't greedy like Windows is, and it only needs 512 megabytes of memory. And this is where the real power of hypervisors come in, because the hypervisor noticed this. He sees that there is memory that isn't being used. So what he does is he tells the operating system, hey, I got 1.5 gigs of memory that isn't in use right now. Do you want it back? And the operating system, being a sane individual that he is, says, yes, I would like my memory back. So now we have more memory than we had when we initially started our VM. And this is called, this particular phenomenon is called memory ballooning, which allows us to control, dynamically allocate and deallocate memory from virtual machines. But it gives us incredible amounts of flexibility, because we can then say, because in a lot of cases with hypervisors, into particular operating systems, especially if you watch like Windows starting up, we need a lot of memory to boot up an operating system. We need a lot of RAM when starting an operating system. But once it starts up, usually the RAM requirement goes down after boot. So we may initially only need 44 gigabytes of memory to start like Windows, but after we started it up, we only need 2 to run what we want to run on that VM. So then we can reallocate that memory back to our pool of memory, allowing us to start up much more VMs than we originally would be able to start. Because like if we go back to our analogy over here, we allocated 2 gigabytes, which left us with only 6. But since we got our memory back because we only were using 0.5 gig of RAM, we now have much more memory than what we initially were with before we did ballooning. So, and then this is where it goes back to what Chad was talking about with the ability to scale and the ability to be very, very, very stringent and just very economical with your resources. Because if we have a server here that has, 32 gigabytes of memory, we can spawn considerable numbers of operating systems that need very, very little RAM to run. They need a lot of memory to start up, but this allows us to run a lot of virtual machines on a single computer and benefit from the isolation that we talked about over here in our farm analogy. So they're incredibly flexible. There's a lot you can do with virtual machines. There's a lot of advantages to them. It can get more complicated when we talk about type 1, but type 2 give us a very good analogy that we can work with as to how it works.
That was really good. Thanks, Isaac. I'm wondering
Absolutely.
if we should talk a little bit about disk too, right? So
disk.
Maybe the concept too of like thin versus thick provisioning. just maybe the high level there too.
Yeah, so I talked about earlier that like our disk is our barn, right? So there's a couple of ways. I'll stick with the very simple one, which is just file system. So we have our file system. Our OS governs a file system, which is literally just a tree. So like, let's say I have my root directory here, and like with Windows, I'll have my users, and then I'll have program files. You can check this in your file explorer now if you're running Windows, but I know I have a couple Linux bros on the call right now that cannot join us. So I'll leave this as an exercise to the reader. But so we have this file system here that contains some data, but we want our VM over here, he needs disk. He can't just, run without disk. He kind of needs somewhere to put data because there's really no point in running a virtual machine if we don't have data. There are some cases, but we're not going to get into the nuance there. The way that it works, again, with type 2 hypervisor, is that we have a VM here. When we create a VM, all the OS does is, let's say we have a path here with VMs. I can't write. And then we can create a disk. So we'll call this like win10.image. And what this is a raw disk. Now, what is a raw disk? It is literally a file that contains the file system. In other words, if you're on Linux, you can actually mount these. I'll type it out here with the command. With sudo mount o. That is the call that you need to do. In other words, all it is it's literally a hard drive in the form of a file. My brush stopped working. No, brush, come back. Guys, I may be cooked. Oh, that's because my selection's off. I've been outsmarted by GIMP. I'm just gonna go to a new one. Man, you gotta love open source software. Anyway, so it is literally a hard drive. You can think of it as like a USB thumbstick, but as a file. It is a file of your USB thumbstick, or a file of like a hard drive. It is a file form of a spinny disk platter. That's what it is. And if we go back to here, if you're on Linux, you can use this command here, and this allows you to view the contents of the file as if it were an actual disk. So there's really two ways to allocate these, though. Hello, Axel. Welcome to the discussion. There's two ways to do this. There's thick. You can make a thick disk or a thin disk. The difference is how it looks to the VM isn't really how it looks, because the VM, if I make a disk that is 64 gigabytes in size, no matter how I provision it, the VM is only ever going to see 64 gigabytes of space. The difference is how the hypervisor sees it. So if I create a 64 gigabyte thickly provisioned disk, that's thick, on my master disk, if we go back to our little drawing here, on my operating system's file system, it's going to take up 64 gigs of space all day, every day. It's always going to take up 64 gigs. So that means if I have 256 gigabytes of disk space on my host machine, or the machine that's running my hypervisor, I can optimistically run 3, maybe 4 VMs from disk space alone. I don't have much disk space. But this is where thin provisioning comes in. Thin provisioning is where we basically lie to the guest operating system, the VM. We lie, and we say, you have a 64 gigabyte disk space. But on the guest, we're only going to store what the VM uses. So if we have a VM, we can go back to like here with the RAM. It's similar to how the RAM works. If I have a disk here that I give the VM and it's 256 gigs of space, right? And then I spawn a guest VM and I want to, but it only uses, 12 gigabytes of space because we're using Linux and Linux doesn't need much space. That means that even though we allocated 256 gigabytes of space on our hard drive, it's only going to use 12 gigabytes of space. This means that if we go back to our analogy over here where we can only hold 3 or 4 VMs, if we use thin provisioning, these 256 gigs stretch to 30 VMs to 40 VMs. An order of magnitude more VMs can fit on our hard disk if we use thin provisioning over thick provisioning. And there are times when thick provisioning is actually nice in the regard where thick provisioning is helpful with performance. Thin provisioning can eat up more space, especially on type 2 hypervisors, because every time we need more disk space. Like let's say I have a file that has 2 gigs. Whenever we need to add more data, we need to go talk to the operating system and ask him to give us more space. So then the operating system needs to go to the file system. He needs to go to the file system and he needs to make sure that there is space to give. And then the file system needs to check with the hard drive and make sure there's actually space on the hard drive
Test.
before. You're through, Axel. Welcome.
Wonderful.
Yes. And then after the file system checks with the hard drive, then it goes back to the file system. The file system then tells the operating system, yes, you can use more space. And then the operating system will then give you more space. So there's definitely a very big performance difference. It's nominal. Thin provisioning has gotten a lot faster in later years, but in cases where you need like a lot of performance, where you need all the performance you can get, thick provision will give you a notable disk increase. It's helpful in particular if you're using hard drives or flash drives, but if you're using an SSD, use thin. If you use anything other than thin, I will slap you. There's really no reason to not use thin provisioning on an SSD.
What about write cycles?
Yes. Write cycles on an SSD.
On an SSD.
The damage is nominal. It's SSDs can handle incredible volumes of torment until the controller begins to fail. Anyway, Chad, you raised your hand. What's up?
Yeah, no worries. Do you want to talk maybe a little bit about some of the risks though within provisioning, right? So yeah,
risks.
Like if you fill up, I'm thinking particularly if you over provision thin, maybe talk about what can happen.
Oh yeah. Oh, so this is fun. This is where things kind of get a little interesting. So thin provisioning has this is where you kind of need to make sure that you don't over provision, because let's say I have a hard drive here. I have an SSD. And this SSD has 64 gigs of space. Now I'm a junior system architect and I get a little greedy and I create a VM over here and I'm going to give it 12 gigs of provision space and I create another VM and he's running a database, so he needs some more space. I'm going to give him, 32 gigs of data. And like, oh, we need a web server, so I'm going to create another VM and he's going to have 8 gigs of space. And I do a quick head math and like, oh, we still have space. So I'm going to create another VM, but this is a workstation system, so it needs to have some more space. I'm going to give it 24 gigabytes of space. And then, oh, I need to have another web server for redundancy. So I'm going to create another web server and he's going to have 8 gigs of space. What's wrong with this image?
Technically, it's okay, right? Because
yeah, it looks fine. Yeah.
Well,
but
you can over.
There's a teeny little issue. There's a teeny little issue.
Right.
If we add up all of these disks, it is greater than the amount of space that we have on the SSD. And in a lot of cases, this is perfectly fine. There's
Exactly.
nothing wrong with this.
Yep.
But what happens when we use more than what we have? The entire system cramps up.
Yeah, and that's how you'll actually take the physical host. Like you can take the physical host down
That's how you can cripple things, yes.
with all those
Because
Yeah.
bad things happen when you overuse space.
you
This
can over
shouldn't-
provision, right? It's like
Yes.
you're talking about, you can over provision, you just can't overuse, right? So
Yes.
just
Yes.
having all those VMs running and allocating that space is actually perfectly fine, and a lot of companies do that. You just have to keep an eye on, what is your actual utilization of those disks, and when
Mhm.
to add additional, disk space to compensate for what's actually being used.
Yeah, and that's where a lot of tools, especially on Linux, have the ability to have alerts when these things overfill. And there's enterprise grade software that will monitor your disk usage and be like, hey, by the way, you're over provisioned and you're getting close to exceeding the limit. You may want to add another hard drive somewhere so that we don't run out of space. And so there's nothing, like Chad was saying, and I'm going to reiterate that there is nothing wrong here. There's nothing wrong with over provisioning. There is something wrong when you do not do your due diligence and have alerts in place, and you don't have the ability to expand, or you don't do your due diligence, essentially, and you're not monitoring, you're not keeping track of how much you're using. Because when this equation happens, very, very bad things happen. VMs randomly crash, your hypervisor crashes, your host operating system crashes. Very, very bad things happen, and it is not pretty. And it can be kind of hard to debug because it's not the first thing you think of, like, oh, we ran out of disk space. Not the first thing you think of, especially if you don't have alerts in place. I cannot emphasize this enough. Have alerts in place if you're over provisioning so that you
And
know
by the
when bad
way,
things happen.
lucky for us, the Ice Age servers do have alerts for us. We usually trigger them
They
when we
do.
take provision, though.
Yeah, and as you will see in our documentation for creating virtual machines, we always thinly provision, especially for Linux. There is no reason to thickly provision because Linux is weird. You never know how much disk space it's going to use. Some days it's feeling kind of thin and you only use 4 gigabytes, and other days it's feeling kind of thick and you use 64 gigs. It depends on the day.
And one point of clarification too, the monitoring that Isaac's talking about is not at like the host VM, or is not at the VM hypervisor level for the individual VMs you're spinning up, because those VMs will look like, hey, I'm only using 12 gig, but I was provisioned, let's say 64. From the VM host level or VM guest level, they won't look like they're over, like the disk is full. The alerting has to happen at the lower level storage array. That's actually where the data is being written, to understand, am I filling up that storage array or not, and do I need to expand that out?
Yeah, and technologies like LVM2 are very robust in making sure that kind of stuff doesn't get out of hand and giving you very good information.
Yep.
So a lot of time, as long as you're just keeping track of things and, like I've been saying, doing your due diligence, you shouldn't really run into issues. Well, what do you think, Chad? I think now that Oxel's here, do we want to try setting up some Linux?
Yeah, before we do that, Isaac, you did a great job. Does anybody have any questions for Isaac?
Oh yeah.
Before we kind of transition into, I think Oxel's going to give us a demonstration of Ice Age and kind of some real world VM setups.
Are we gonna run VMs today?
That is the goal. We want to try to get you guys hands-on with setting up Linux. We will be using Linux a lot in every competition. We use it for web servers. We use it for databases. It's like the backbone of our infrastructure. So we want to get you guys familiar with Linux as soon as possible.
So
So
when we
that's
do,
kind of the hope. That's kind of the hope.
when we do it, should I use my PC or my laptop? Because my laptop doesn't have, it's like not the best 8 gigs of memory, but my PC has
So-
32 gigs.
You're gonna use Ice Age.
Oh,
Yeah, we're not putting virtual machines on your own computer. We have someone else's computer in the cloud. It's ISU, and they're letting us use their computers for virtual machines. It's very nice of them.
okay.
Yeah, but any other questions?
Can you say like all of that all over again?
Is there
yeah, go
something that
ahead.
you didn't catch in particular, or is it just
Yeah.
is it
Can
just
we
a lot?
start like? Can we start over at what happened at 10 o'clock?
Happened at
No, I'm
10
just kidding.
o'clock. Okay, good. I'm like I can't I direct you to rewatch the recording.
Right. Yeah.
We
Hayden,
are recording, right?
we
Yeah,
do.
we are.
We have a recording.
Yeah.
But is there a particular question you had, or some of this, some of this might make more sense after Oxel kind of goes through the real world stuff as well.
Yeah.
This is a lot of theory. Yeah, so I don't blame you if you're feeling like overwhelmed or like, oh my goodness, this is so complicated. I don't blame you. This is
Yeah.
just theory. But it sounds like, yeah, Oxel, do you want to go ahead? I'll stop screen sharing. You want to take the reins from here and get our feet wet here with some Ice Age?
Yeah, absolutely. Yeah, is everyone ready?
Yeah, I think so. I think Hayden, it might make a little more sense as he kind of
God.
goes through the actual VM setup and things of that nature there. So
Yeah, so I'm gonna be screen sharing here, but I'd like all of you to just follow along. So if you could open up a new tab here, and I'm gonna paste the link in the chat here, but we're gonna go to iceage2.iceage.org.
and Oxel, you
uh,
said you can't share, or you're trying to share.
I'm gonna share here. I'm just pressing the button.
Got
you
it.
may also need to walk them through how to create an account with Ice Age so that we can get them on the team and get them to where they can they can access vSphere.
Yeah. Actually, no, we have a shared team account here for
Oh, wonderful.
iceage2.
Okay. Splendid. All right, we're good then.
Where's my?
Put me to
There
the
it is.
vSphere. Okay, I say. So do I just put in my email and password?
So no. So what we got here, we've got iceage2 loaded up. Let's see. I should actually just go to the actual link here. So iceage2, we press the launch button, and we got this screen. Up here in the username field, we put school 14, and then for the password, I'm gonna paste this in the chat here. You put that as the password.
And just a note here, guys, don't share that outside of this club. This is just for our use, internal only. I just want to make sure we're on the same page there.
I did mean to delete some of these machines.
Yeah, I do want to reiterate that what Chad just said. We can't change the password without going through a lot of hoops. I do not share this outside of our group. I want to make that abundantly clear. It's not going to be a fun time if it leaks.
Sorry, I already posted it all over Twitter. My bad, bro.
Ah, man.
Shucks.
So yeah, just want to confirm here. Everyone's gotten this far. They've got the login screen.
I don't have all the options that you have on the left.
That should be all right.
Yeah.
You might need to zoom out or something here. But yeah, just let me know when everyone's gotten this far.
I'm at it, but I only. Oh, hold up.
I typed the password in.
Okay, I fixed it.
All right, so once we're here, just make sure you're on this first tab here. I'd click on that. And then, yeah, just open all of these. We're going to go down here and we're going to see School 14. And that's ours. We are School 14. Unfortunately, it doesn't match our team number, Team 5, but it works. Now on School 14 here, we go to Actions and we make a new virtual machine. And that takes us to this screen. And throughout our semesters here, we're going to see this screen many times. And it is definitely an ugly interface, but it works. Let's see, I'm consulting my docs now because I forgot what I do next. So assuming we're actually creating a virtual machine, yes, we are. We choose create a new virtual machine, which should be automatically selected here. And we click next. Oh, next. And so that'll take us to this one. And this wants us to select where we're storing, like what group we are, who owns this machine. So we just open all these up and choose School 14. And then for our name here, I'm gonna, for today, we're gonna type your name, add a dash, and then Ubuntu, and then colon first VM. Just like that.
How do you spell Ubuntu?
It's on the screen there, but U-B-U-N-T-U.
B-U-B-U-N-T-U. And does caps matter?
Not at all. It would if we were actually doing anything with this, but we're just having fun right now. And also, this is just our team's naming convention. You don't have to name it this. This is just what we like to have it named. So once we've selected School 14 here and named our virtual machine, you can hit next again. If I'm going too fast for anyone, just please let me know, slow me down here.
Yeah, real quick, show of hands. Is everybody where Oxel is right now? Is everybody at the same level? Isaac, Hayden.
Yep, I got this. Yep.
Okay, perfect.
All right. Cool. Yeah, so next it's going to ask us our compute resource here. And this is what thing is going to be like running a processor, running all the hardware, just like this is what computer it's running on. And so for this, just like the last step, we're going to choose School 14, which is, you might have to open some of these folders here, but yeah, School 14, because that's us. And now we get to a fun part. We get to choose where we store this.
Did we choose where we stored it earlier when we put School 14?
No, that's so the first one we did, that's who owns it. The second one we did is what machine is computing, like running all the resources for it. Now this is where we put the machine on like physical storage. We always select high school storage. It's Playground ISO data store. Yes, Chad.
Hey, as we're going through this, Axel, I'd like to kind of circle back some of the concepts that Isaac talked through, which was the storage, CPU, things of that nature, just to kind of tie things together for the students. You're probably going to do that, but I just want to kind of point that out as we kind of go through the screens.
Yeah, I'm gonna get more to that, especially once we start configuring the machines. But yeah.
Perfect.
So yeah, we select this, and they've got a good bit of storage here, which is nice. 10 whole terabytes for all the teams, including us and other teams. And yeah, high school storage is what we put it on. Playground ISO data store, we're going to use that later. That's like install files for various operating systems. So yeah, we put it there. We don't have to worry about anything else, just high school storage.
Hey, real quick, if you go back, so that is the storage array that we were talking about earlier, right? So you see how it's got 10 terabytes, right? 10.2, and it's got 4.36 terabytes free. So that's basically the storage array that Isaac was talking about. If you fill that up, that will have problems on the underlying infrastructure, right? Just kind of tie those things together.
Eden, did you have a question here?
I was about I accidentally raised it. I didn't mean to.
Oh, all right. Just making sure here. So yeah, after we've selected our storage, it's going to ask us compatibility. And this, we usually don't have to worry too much about this. We just set it to what we're going to install. But honestly, I don't even know if it does anything. Do you know if it does, Isaac?
I'm sorry, I stepped away for a second and now I'm back. What are we looking at? Oh, the compatibility.
Does it actually do
Oh, so
anything?
it does actually. So the compatibility with, if my understanding is correct, with vSphere, that is for hypervisor hypercalls. That's used
Oh,
for ballooning and VirtIO drivers.
so just make it simpler for stuff to work, less overhead.
It's how you can make things work. Always set that to the high. For in ARC purposes, you want that to be the highest compatibility mode.
Oh, I'm sorry.
So
I was
7.
confused between that and guest OS.
Yeah, the compatibility is for the hypercall compatibility layer.
Never
You
mind
want that
then.
to be
Yeah,
7.0.
this one, we always set to the latest one, which is the default, so we don't have to mess with it. So we just click next here. This is what I meant to talk about. So this one, it asks you what you're planning on installing on the machine. Yeah, I don't think it does anything, but it's just nice to tell Ice Age here so that if there is anything they need to know about it, they know.
There is a tad difference, which at least with Windows and Linux. Don't set guest OS for Windows if you're doing Linux and vice versa. Again, this is for virtual IO drivers, and long story short, it's so that it works out of box and you don't run into weird cryptic issues in the future. Just to realize is because you put weird parameters when you created the VM.
Yeah,
It does
so
actually serve a purpose.
what we're going to be installing is Ubuntu here, which is Linux. So for the first box here, we click Linux. And once we selected that, it's asking us what kind of Linux we're installing. So might take a little bit of a scroll here, but we're going to choose
Real quick, Axel,
Ubuntu Linux
Haddon,
64-bit.
what's up? I saw you raise your hand.
Could you go back to step 5? What was the selection that we had to pick again?
So it'll by default choose the one with the biggest numbers here, and we just
Okay.
want to leave it at that.
Okay, thank you. Sorry.
It's all right. I was confused, and I think I confused other people because of it. So yeah, once we got this, we got Linux and we got Ubuntu Linux 64-bit. Never set it to 32-bit because we don't have that. So yeah, once we got this, we hit next. and it's going to ask us about hardware. This is one of the trickier steps, but basically what we're doing is we're choosing how much of the physical hardware of the, I don't know what you call it, the hypervisor. But we're choosing how much physical hardware here we're giving to this machine. So there are some guidelines here in the docs. Yeah, there are. So what we choose for CPUs, we choose typically any number between 2 and 4. That's inclusive, so you can choose 2 or 4. Since we're just making this as an example and probably not going to do much with it, we're setting it to 2. So two CPUs here. For memory, with Ubuntu, I personally, I guess it's Ubuntu server, so I don't know. I'd like to set this to 3 gigabytes. You could set it to 4 or 2 for this. If we were doing something really intensive, we might set it higher. But maximum for our machines should be, yes, Isaac.
For Linux, you'll want to do 4. Linux will throw a hissy fit if it runs out of memory.
You're right. It does say that in my docs. I wasn't looking at my docs. Yeah. So yeah.
Very
gonna set
W
this to
of
4.
Linux for that.
Yes, Isaac.
Yes, I agree. No, I just got to unraise my hand here. There we go. Cool.
Yeah. I mean, you could install Puppy Linux. That doesn't need a lot. But we're not doing that. We're installing Ubuntu. So, yeah, 4 gigabytes of RAM is good. For Linux machines, we could put it between like 4 and 8 gigabytes. That's usually reasonable. For Windows, 8 gigabytes should be enough. We could set it to 16 if we really wanted to, but just completely max it out at 16. We don't want any more than that because that's wasting resources. So yeah, 4 gigabytes of memory, 2 CPUs, hard disk. And this is what Isaac was talking about with thin provisioning and stuff. So under the hard disk, we want to open this one up. And what we've got, disk provisioning right here. We want to always set this to thin provision. Because yeah, what he was saying there, if we set this to thick provision, we take up actual storage. If we set to thin provision, we only really take up as much storage as we need. And then we're also going to choose an amount of hard drive space here. Honestly, for this, I'm going to set this to like 32 gigabytes since we're
Can you
not
slow
doing
down for a
anything with
second
this.
and let me copy everything down real quick.
Yeah, absolutely.
32. Okay. Location store. Thin revision. Okay, so I think that is. Okay, I think that's everything. Thank you.
So yeah, thin provision, 32 gigabytes. Yeah, since we're not doing anything really with this machine, if we were doing useful stuff or anything with this, we might set it to like 64 gigabytes. If we were doing a lot with this machine, we might set it to like 100, but that's getting close to excessive, honestly, for a Linux machine. So yeah, 32 gigabytes is what we're setting it to here. What else have I got here? Yeah. And yeah, just remember, these are, as much as these machines aren't real, they're taking up actual space on a real machine. And Iowa State is nice enough to let us use that machine, so we're gonna do our best not to overutilize their resources when we don't need to. Yes, Hans.
So are we taking up today like a 96 core thread with her or something? Are we taking up 2 of those cores or what?
So yeah, if kind of. So if we set this CPU to 2, which would be 2 cores, that will take up, depending on how the virtualization works, that can take up 2 actual cores on the server, or if this machine isn't doing a lot, it could, not use those cores for a little bit. I think it works kind of like threads rather than cores, but honestly, I'm not sure. Yes, Isaac.
Yeah, so on that with the CPUs, I didn't talk on that in my little presentation, but like what Oxel was saying, it really just works like a thread. If you know how programs work, it just has like its own thread. It's the same way with hypervisors. It's really just a virtual machine is just a glorified program. It behaves very, very similarly in that regard. So when the CPU isn't doing anything with the virtual machine, it's not going to be using any CPU time unless it needs that CPU time.
Okay.
Right,
But if you fork bomb your machines, then it will use a full core.
yeah, and that's how you basically, same concept. You over provision CPU, but it's shared. It's shared across multiple VMs, and basically it's time allocated. So whatever cycles or threads are in use at that time, it shares those underlying physical cores.
Okay.
Good question, because that is a kind of a very important concept to understand, is how these resources underlying are actually kind of being used there. And on that note, I do want to add to what Oxel said, just to kind of help the students here. Let's just make sure at this point we only spin up 1 VM per student for testing, because if we do over allocate or take up too much space, Iowa State will reach out to us, and we do have to shut things off. So just be conscious of that, and just set up 1 VM for testing for now per student.
Okay.
All right, so we've got all the actual hardware here configured. I think the last thing we do in this menu is set up our install media. So this is with Linux especially, but also with Windows. You have a thing you boot from that basically sets up the operating system and gets everything ready for you. And we've got to set that up here. So under new CD DVD drive here, what we need to do is configure this. So it says client device here. And what we want to change that to by clicking on it is data store ISO file. And this is what I was talking about as that install media, and also the playground ISO data store, where it will take this install media, this ISO file, and install Linux or Windows. In this case, we're installing Ubuntu Linux. So over here, it's going to ask us for a file to use. We're going to go under Playground ISO Data Store here, and it should show up this menu in the middle. From here, we're going to choose Ubuntu Server 22.04.iso. And if they have a different Ubuntu Server ISO file here, just go with the one with the bigger numbers. That's usually a good rule of thumb. So yeah, we click this and we hit OK. And then we're going to also click Connect at Power On. We're going to check that box here. And if you don't,
real
if you
quick,
don't
does
see that, you have
everybody
to open this.
Does everybody
Yeah.
know what an ISO is? Like when he selected that, does everybody understand what that really is?
I don't think I do.
Axel, do you want to kind of explain that real quick?
I think I kind of did here, but yeah, basically, in the ISO file is, it's basically like if you had a CD or a DVD, but instead of being a physical disc, it was a file on your computer that exactly matched the contents of that disc. So, yeah, it's one of what we call a disk file. There's also IMG files. Those are also disk images. But an ISO file here, that's gonna be turned into a pretend CD here. And that CD is something we insert into our pretend computer here to install, in this case, Linux. Very useful. So yeah, now that we got our file selected here and we've selected connect at power on, this is going to be able to install stuff. And then I think that's it here. So we're going to click next. And yeah, it says ready to complete. So yeah, I'm just going to scroll through this here, make sure I've got it all right. You can scroll through yours as well, make sure it matches what we set up in these steps, if you remember them. It does look all good to me. So yeah, and then just click finish. Hooray! I've created a virtual machine here. Oh, Haddon just made one.
It said operation failed.
Well, it succeeded for me here.
And on mine it said operation failed. Perhaps may create virtual machine. Targets full port status invalid configuration for device 5.
Huh.
Hey, Hans, we're having a hard time. At least I am. I'm having a hard time hearing you. Is that the same for everybody else here?
Yeah.
I can't understand a word he's saying.
Yeah, you might have to talk more direct from the microphone, or I'm not sure.
It's too close.
I can barely make out what you're saying.
Oh, that's good.
You might have a microphone that's like in a laptop or buried or something.
Yeah, so I got Haddon's here. Actually, yeah. Yeah, do you mind pasting here your like a screenshot or something in the Zulip? Because yeah, maybe copy and paste the text. Because yeah, I'm actually not seeing it here. Yeah.
It went away, the little error message.
Oh, all right. Yeah. So yeah, then it probably did fail here. And we can troubleshoot that later. This would be a lot easier to troubleshoot in person. Kaizek, have you been following along here? Do you get stuff set up?
Mine failed too, like had it.
All right then. Yeah. Well, we've got.
Are you getting what error are you getting? Did you ever catch that?
Did you get the operation failed error, Isaac? That's what I got. That's what it said.
Yeah,
I'm looking at the recent tasks, and it looks like we're all getting the same error, which is an invalid config for device type 4.
For what?
Device number 4.
Oh,
I got device number
It's
5.
the CD DVD config. Okay, one
oh
second.
yeah,
I'm
that
gonna
would
try to
explain
debug.
it.
1 second. I'm gonna try to figure this out. Hold, please.
There is a thing where it's kind of tricky to make sure you've selected the right ISO file and that it's actually selected sometimes. For those of you that failed here, you want to just follow along with me, just briefly make a new VM with me here, just so that you have one for our stuff. Just try again, right? So yeah, new virtual machine, create a new virtual machine. I'm gonna name this.
Wait, so I don't see an error message on mine.
Well, that's good.
So should I
Yeah.
just? Should I
Yeah,
just?
your VM's good to go, Hat.
Yeah,
Okay,
yours is
good,
good.
good.
This,
Bro, I'm
just
so
for
good at
those,
this.
yeah, for those who did have issues here, we're just gonna make a new one again. So yeah, follow the same steps here. So yeah, you go to school 14, you click actions and create a new VM. Select create new virtual machine and click next. And then you name it similarly. So your name dash Ubuntu colon first VM. That should work for you. And then open up these folders until you see school 14 and select that. And then after this, you go and open the folder, select school 14 again. And click next. And then you select Playground ISO Data Store.
I thought it was high school.
Oh, sorry. Thank you. I would have messed stuff up there. You do select high school storage. Thank you. Yeah, so select high school storage. Click next. It'll ask you for compatibility. We click next. For OS family, you choose Linux. For OS version, scroll down and find Ubuntu Linux 64-bit. And then click next here. Then to CPU, memory, we changed that to 4. Hard disk, we changed that to 32. And then CD DVD drive here. It says client device. We click that and we change to data store ISO file. And then just watch along here with the video, with my screen share. We're gonna have to click Playground ISO data store, click Ubuntu server, and then
Hold up.
Yeah.
Let me share my screen. 1 second.
Yeah, go ahead.
Where's the share screen button?
It's at the bottom. It's the laptop with the up arrow. Yeah, that looks right. So, oh, I'm trying to get a better view here. There it is. So, yeah, you do that and you select Ubuntu _server _22.04.iso. And the OK button should turn blue. We click that.
Yep.
And then we also make sure, oh, where did my window go? There it is. We also click the connect at power on button here under status. If you don't see that, you have to flip this open. But yeah, that should be good. We click next and we click finish.
Okay, click next and then finish. It said operation failed again. I'll try.
Yeah, can you share your screen here?
Yeah, 1 second. Oh, yeah. Oh, the thing just won't get that. I got a screenshot of it, so I'll share my screenshot.
All right.
How do I share my screenshot? It's not letting me share it in the chat.
You can share it on Zulip here.
Here, here, I can send a screenshot of what my mine looks like.
All right.
Should I? Okay. Yeah. What should I share it in Zulip?
If you can go to meetings and homework and then the 2025 10-11 meeting.
Crap. I have the screenshot saved to my copy and paste, right? But it's not letting me paste it into the Zulip message thing.
Should let you here. It should show up as just text when you paste it, but yeah, it should
Yeah,
let you.
Let me try again. Worst case scenario, I'll just share my screen.
Well, I tried to share it and it went to a link. Like.
Yeah, it's supposed to go to a link. It's supposed to go to a link.
The link doesn't go to anything. I went to that link.
There.
Yep. Yeah, Zulip is weird like that. So,
Here, do you want me to just share my screen?
Sure.
Yeah. That operation failed thing is like, I don't know.
This is what mine looks like.
Yeah, that looks all good. You've got your VM over there.
So if yours looks like this, then you probably did it.
Yeah, but yeah. Hans has got an issue here.
Oh crap.
Yeah, so
Okay.
does Isaac.
I got mine figured out.
All right. Yeah.
That error is weird.
Yeah, that's a weird error, and it doesn't even say anything.
Yeah,
Oh shoot.
What?
Isaac, do you see this? It's a seg fault in PF sense.
Huh?
Isaac, are you there?
Yeah, I'm here.
It's
I don't
a
know,
seg
man.
fault. Seg fault
It's
in
kind of
PF
crazy.
sense.
Kind of crazy.
Okay. Yeah. So yeah, I don't know what's going on here.
Okay, so what I found, I actually think I found out the issue. You can only use Ubuntu server ISO. There's some weird permissions. I don't know what's going on, but I can't get it to work with anything other than Ubuntu ISO
Then why do I have permission?
because you use the Ubuntu ISO server ISO.
Well,
Are you guys? Yeah. Are you guys selecting Ubuntu server specifically?
Yeah. I did the
Not
exact
Ubuntu
one you
desktop.
said.
Yeah. All right. I'm honestly not sure then here. And Kaizek, you said you got yours set up.
Yep.
What's yours named here?
Kaizek Ubuntu VM, I believe.
I see. Yep. And you looks like you've already powered yours on here.
Yeah, I already got mine set up.
All right, cool. Yeah. I don't know. Should I show people how to install Ubuntu then?
Yeah, I think so.
I'm down.
What do you mean? Like install the actual operating system or what?
Yeah.
Yeah.
And Hans, I'm just gonna go through real quick, make you a virtual machine here.
Okay.
Since it seems to be working for me.
And me. I can't imagine what you guys are doing differently, if anything.
I'm doing the exact same thing that, like,
Yeah.
I think what you guys are doing.
It's hard since this is such a long process to do it perfectly every time. So
Also, I'm now
Well,
downloading. Am
yeah.
I downloading a new operating system to my PC or to my virtual PC?
To your virtual PC that you just
Okay.
made here, and
Good.
you don't have to or even worry about downloading it because it's already downloaded onto this ISO file here.
Okay.
So ISO data store.
By the way, you're not sharing your screen, just in case you didn't know.
Yeah, I'm just setting up. Maybe I should be sharing this, but yeah, I'm just setting up one for Hans here. Where is
Just thought I'd
my?
let you know.
Yeah, thank you. Yeah, so Ubuntu server. Connect that power on. That looks good. Ready to complete. Finish. Oh.
Oh, there it is. Yeah.
Yeah.
Huh.
Okay.
Could it be my name? Like, what name
That's-
did you use?
Yeah, I just typed in Hans -Ubuntu : first VM. So it could be a name collision or something.
How?
Hans U
Yeah, I see the difference.
Ubuntu test VM. I don't know. Just call it that. Oh, that one. Yeah, actually, since stuff is, that is the wrong storage.
Playground.
Ubuntu server. Connect power on.
Yeah.
Okay, I think it was a name collision. That's stupid.
Weird.
Could it be the colon in the name?
No, because there's a colon in these other ones. It's the
Oh, is
exact
it?
same format as these other ones. My assumption is there's some other team that has a VM named exactly that,
That's odd.
which is quite a coincidence. But yeah,
Well, then why would
you
it
should
work for me since I did that same? Unless since
someone else doesn't have a VM named Haddon Ubuntu.
Oh, okay, yeah. But someone
Yeah.
might have another one named like Isaac or Kizik, yeah.
Yeah. So Hans, you should see over in your left panel here,
Yep, I got
your
it.
VM here. So yeah, in the left panel, we're gonna select our VM.
Yep.
And we're gonna press the green arrow at the top here that says power on. And then it should start powering on. We're gonna press the blue button here. Once that shows up, launch web console. This is where it gets fun.
How do I?
Wait,
do I
so
use
I'm
my
doing
keyboard for this?
You will need to use your keyboard in a bit here.
What do I do? Where do I go?
So yeah, in the left panel here, you're going to select your VM. You press
My
the green.
VM.
You press the green arrow up here, the green play button, and then once that is clicked, there's this button here, launch web console, should turn blue, and you're going to click that.
Hey, yeah, I got it all set up.
Yep, I'm
Yeah,
setting up.
It should look something like this here.
Yep. Mhm.
And
Whoa,
I'm
wait,
gonna
hold on. Wait. Do I press try and install Ubuntu server or test memory?
just let be. Don't touch anything. It should start doing this.
Okay.
I'm just gonna resize this because otherwise I look blurry.
That's good.
Oh, there we go.
And yeah, it's gonna take
Yeah, you're
like
a bit
a
ahead of us.
minute to start here.
Bro, this is what it looked like on Isaac's computer last week.
It's magic, ain't it? My computer does this as well.
Everybody's computer can do it. It's just whether they choose
Windows can't.
how to do it. Windows can't. What about Windows Server?
Yeah, Windows won't show you startup messages at all. It's kind of disappointing.
I know, it makes me feel like a hacker every single time I see something in a black background with green code. Makes me feel like I'm about to access the firewall.
Yeah, so yeah, the fun part about this is, oh, it's booted. But
Gotta choose my
the fun thing
language.
about it is it's telling you everything the computer is doing as it starts up. So like it says setting the date and time or launching network services. It does absolutely everything and tells you as it does it. It's quite amazing.
My keys aren't doing anything. My keyboard ain't doing anything.
Right. So what we're gonna do here, it's gonna ask you to select a language.
Can we wait till everyone gets booted first?
Oh, yep,
Before we
yep,
start moving
sorry.
on. Thank you.
Yeah, just raise your hand once you're
Alright, I'm
booted up
booted.
here and see this screen.
Yep, I'm booted too. I'll just say that.
Yep. And then Kaisek's going on his own. I'm not going to interfere with Kaisek.
Kaiser's in his own little world.
Yeah. So once you have this screen, it's asking you to select your language. So what first thing you're going to do, you're going to click into the window. So just like move your mouse where it goes hidden and click. And that should activate your keyboard. So yeah, just
let's choose Dutch. No, I can't.
yeah, so go to English here. It should be the default option. Press enter. Next, it's going to ask you about keyboard layout. I doubt any of you except me use Dvorak, but I'm not going to use that for this.
What's the foreign?
Different keyboard layout.
Oh, okay. I had that
Also, if you-
EFG keyboard. No, I'm
You're
just kidding.
evil. But
Yeah.
even if you did use a
QWERTY.
non-QWERTY keyboard, do leave this at QWERTY, English US, because otherwise you're going to have the mappings done twice and it's really weird. So yeah,
Ew.
English there. It's going to ask us what we want installed.
Which
We're
we
gonna
push
say-
done.
Yeah, go back here. Yeah, so just choose done on this. Don't have to worry about setting it at all. It's going to ask us what type of install. By default, Ubuntu server here is selected. We want that. There, since we're doing actual things with these servers, as a team, when we set stuff up, we almost never want to choose Ubuntu server minimized.
What's the difference?
Ubuntu server, the non-minimized one, has a lot of pre-installed programs that are really useful. Minimized has basically nothing installed, so that
So it's
you
better
don't
for
have-
like people that are more experienced.
No,
guess.
it's better for people who are doing less things with the computer.
Oh, yeah.
Yeah.
Or
So yeah, I tell you that.
or from like a security hardening perspective, sometimes you'll select the minimize and then just install the packages that you want to install.
Mm-hmm.
Network.
Yeah.
This whole personal computer thing is so interesting.
Yeah, it is.
It's neat. I like it.
That's why I run Linux.
Yeah, I think I'm starting to like Linux. I
Yeah,
think
so
you
it's-
guys might have converted me
Woo!
You just
to
made
the dark
actual
side.
Isaac smile.
Yeah.
I don't think you understand how wide my grin is right now, hearing that after spending the last 2 weeks giving me crap about using Windows, about using Linux, here you are. You have
I
become
think
Isaac,
I'm
one of
did you
starting
get
us.
your
to.
camera
I think
set
I'm
up?
starting to prefer the hungry pack of wolves on the plane a bit less.
My
I
camera?
think they're both a hungry pack of wolves on a plane. Just one you let them eat you, and the other one you run away, but you don't have room to run away.
That's when you pull the parachute and open the evac door.
Okay. Yeah, so Ubuntu server selected here. We press enter on done. Next, network connections. The way the network on the Ice Age playground is set up, we basically just configure all networking manually, or at least that's how I like to do it. Some other team members have differing opinions, but for this, I'm gonna press the up arrow till I select ENS 192. Press enter on it. Go down to edit IPv4. Press enter on that. Press enter on this and select disabled.
Oh, say that again.
All right, so yeah, we go up until we go to ENS 192. Press enter on it. We go down until we get to edit IPv4. Press enter on that. It's going to ask you a question here. We press enter on it and select disabled.
Okay,
And then
I see.
we save it. And let's see. Yeah, IPv6 is disabled by default, so we don't need to mess with that. We're going to set this up later. Just for now, it's, in my opinion, better not to touch it. So better to disable it. So yeah, we continue without network. Then it asks for proxy address.
Well, sorry for interrupting, but so do I count?
Yeah.
Do we go continue without? Okay, yeah, I see.
Yeah, continue without network.
I see.
Yeah, there you go. Next is going to ask for proxy address. We do set up a proxy, but I like to do it manually. So for here, just click done. Then it's asking about a mirror address. You don't have to worry about that. It's just like where it downloads programs from. So you can click done.
You mean continue without updating?
No. The done on this step, the mirror address step. Then it's going to ask you if you want to continue without updating. You are going to select continue without updating, though.
I see.
So now it's asking about storage configuration. So this is how your machine is going to decide to use the virtual hard drive that you've assigned to it. If you know what you're doing and you're a more advanced Linux user, you can mess with this. But for our purposes, usually all we're going to do is select use entire disk and then go to the bottom and press done. And then I'm just going to review this here. This does all look good to me. And yeah, usually just take a little time, make sure this matches up with what you set up. It should. And then confirm destructive action. This will destroy any data on this virtual hard drive. Luckily for us, we have no data on the drive, so it's fine to destroy it all.
And that pops up by pressing done.
Yep, that pops up by pressing done here.
So we can then we push continue.
Yep, go down to continue and press that. Woo! It's asking for setup profile. So profile setup here. This is how your computer is going to talk to you and also the other computers on your network here. So for your name, you can just put your name. You don't have to, but you can, and maybe you should. Your server's name. This is the name it uses when it talks to other computers. It says that right under the field here. For this, you can put what you want. Just make it like all lowercase letters with maybe some dashes and numbers. For me, I'm gonna set this to Oxel dash. Oh, where's my dash key? Ubuntu1. Oh, that was my microphone. Yeah, so that's my server's name. You can call yours something else if you want. You could call yours the Death Star. You don't have to, but you. Next, username. This is who you're going to log in as. Whatever you like here, as long as you remember it. So actually, what I'm going to have you do here, Windows users, you can open up Notepad. Linux users, you can open up your favorite text editor. But open that up here, and I want you to write this down here. So
Can I just set mine to Goku?
your username?
Yeah.
Yeah, but I want you to write this down. So let me pop this out here.
I set my server name to the-black-pearl.
All right, so don't press OK yet here. I'm gonna share something here. Where is it? Right, so in your favorite text editor here, I want you to write down host. This is where the field on your setup here that says your server's name. And I want you to write down what you named it. Next, next we're going to put user. This is your username. And Haddon, you said you chose Goku.
Yeah.
Yeah, so you'd write that down here. I'm just going to make my username Oxel. But yeah, you're going to want to write that down. And then finally, your server needs a password for your user. So I like to write pass. You could write password here. And I don't know, just choose like a secure password, something like that, and write it down here because you're going to want to remember your username and your password so you can log in later. Just, yeah, make sure you write stuff down. So I'm gonna, just a moment here. Yeah, so I'm gonna choose a password here for myself. You can choose a password for yourself. Gonna enter it into both these boxes.
Then do we push done?
And yep, once you've entered your password, press done. It'll tell you if the passwords don't match. And if they don't, make sure to retype them. So next it's going to ask if you want to install OpenSSH server. For these ones, we're not going to do that. Usually it's something useful you're going to want later, though. So honestly, I just install it even though we're not going to use it. So yeah, I changed my mind. You do want to install OpenSSH server. So go ahead and check that box by pressing enter on it, and then go down to done and click that. All right. Next, it's gonna start installing. That's fun. It might have a couple errors because you don't have network set up. Hopefully, yeah, usually these errors are not problems that you actually have to fix, but it will tell you that it's upset. And yeah, it just, oh, that was fast. So yeah, at the top here, you can see it says install complete. And sorry, I had to sneeze there. And once the install is complete, you can go ahead and press reboot. And it'll say, please remove installation medium and then press enter. You don't have to worry about that, just press enter.
We gotta go to Plato's today, Dad. Wait, press enter. Yep.
Yeah, it'll say remove installation media, then press enter. You don't have to worry about that, just press enter.
Okay. Hey, Penny. Sorry, that was my dog.
And then it's gonna reboot into your freshly installed Ubuntu, and you've set up your machine. So with that password and username you just wrote down, I want to log in.
Cool. I got it.
And it should launch you into a bash shell like this. That work?
Yep.
Hooray!
Wait, what?
I will give you a couple status messages here. You don't have to worry about that.
The heck?
I
put in my password, right? But even when I was pressing, not even like stars would show up, and then I pushed enter, and now the code's just like frozen. Oh, never mind.
Yeah,
It's
might
loading.
take a bit to log in. It will not show your password with stars. That's one of the fun things about Linux. It doesn't go your password back even at stars.
All right. How do you get rid of all that text that it just wrote out?
Oh, why did my machine close? So to get rid of that, just type in the word clear and press enter. Just run the clear command like that, and you should have a shell like this. You see
Wait,
that?
what?
Yep.
So to get rid of that extra text it dumped on your screen there, type in the word clear, C-L-E-A-R, and press enter.
Nice.
And now we're in our virtual machine, and we can do stuff here. And from here, we definitely don't have time for it, but we set up like networking and stuff. We've got a whole proxy to get set up. We could install some server software, set up our computers so that we could SSH in instead of logging in through this web view. All sorts of fun stuff. But I don't know. I think that's about good.
Yep, no, that's perfect, guys. Isaac and Axel, you guys did a great job today. The goal of today was just kind of go over the concept of hypervisors and then get the initial kind of setup. Make sure you guys have access today because the follow-up session next week is kind of building on this and then going into some of the things that Axel just talked about as far as the setup and configuration of your VMs there. So we have a few minutes. We have about 15 minutes left in this session. I wanted to, first off, because this is Cybersecurity Club, I wanted to point out one major that I want to caveat this. The seniors can't talk about, can't respond here. I want the other guys on the call to respond to this question. But can anybody point out one of the major security flaws that was introduced in this session? If you got it, raise your hand. Aiden, go ahead.
Maybe I hadn't. Maybe because we were doing it on just like an open browser.
Say that again.
Maybe because we were doing it on like an open browser.
Nope, that wasn't it. Hans or Kai?
Honestly, I'd like to know because I don't know.
Is it like with the
Yeah, what do you mean by that?
Oh, somebody was going towards it. What I heard? What did
Is it
somebody?
like with the passwords or something?
Yes, that's exactly it. So, one thing I want to talk, because this is cybersecurity club, so we got to talk about like whenever things like that happen. Because this is a recorded session, so you always want to think about security, right? So these videos eventually end up on YouTube or just they end up somewhere, right?
Yeah.
Well, if you're ever going to share a password, it's better to have a separation of duties, is what it's called. So you want to have like it's okay to share the link, right, the URL, but a better approach would have been to share the password like in Zulip. And so I want to kind of talk about the reason why, because Zulip has a smaller audience, right? So there's a separation of duties. And so anybody viewing this file, this recording, they would have the URL, but they wouldn't have the password, or they wouldn't have the second basically factor to get in, right? Mm-hmm. And so those are the types of things you want to think about, especially in Cybersecurity Club. And those are the types of things, even during the competitions and things like that, to kind of think about. Now, what I'll do is, and again, these things happen, but what I'll do is I'm going to scrub the video. I'll try and cut that piece out. It'll be a little bit of extra work for me before that goes public. But I just want to kind of talk about those things because they're things you want to be conscious and aware of. Because I
didn't think the password got shared here. Like I posted it in the chat. I don't know if that shows up on the recording though.
I'll go through. I'll double check, but I know it popped up. So like either way, you kind of want to just things you want to be careful of. You know what I mean? Kind of have those.
Absolutely. Yeah.
Yep.
Better safe than sorry.
Yeah, exactly. And you guys will have these things, even like if you work for a company someday, you'll have recorded sessions just like this. And so you always want to be kind of keeping security at the forefront of your mind.
Why is this recorded to begin with?
Well, good question. So it's recorded for the students. You guys can replay it. If maybe there was a concept you didn't quite pick up the first time, you guys can review these sessions. They're also for maybe new students, like in the future, if there's sessions that they want to go back to and kind of, it's meant for more learning and things of that nature. So what happens is Chris will take these videos, and we have a public YouTube channel, and they're posted out there for you guys or for anyone that is interested in the club. Yeah, good question.
I feel like I like this Google Meet better than Teams for some
Real.
reason. Yeah.
That's because I didn't have to wake up early to get up and get dressed and actually go somewhere.
Well, I mean, like the actual using Google Meet versus using Google or Teams.
Got it. Yeah, we could talk. I know we're looking at different options. So we should talk about that as a group, kind of take that into consideration there. But we have a few more minutes. Does anybody have any follow-up questions or anything for Axel or Isaac on what they covered today before we wrap up? Sounds like we're good. Well, I just want to thank you, seniors. You guys did an awesome job. Isaac and Axel, I think you did a great job kind of walking through the different concepts here and really helping guys on the team there. Oh, Isaac, real quick, Mike. what is the default gateway? Oh, yeah, go ahead.
Yeah. So, oh, why is my?
Am I coming through now? Hey, let's go. I fixed it. Yeah, the default gateway. I'm trying to set up. I'm gonna try messing around with PFSense and OpenSense.
I'll send you the docs link.
I'm using
You're using Ubuntu server, right?
144.7690. Yeah, I am.
Yeah, use that docs.
Got proxy for Ubuntu. All right, I think I have it.
Yep, it's got
I mean,
everything just completely covered.
All right, wonderful.
Yeah. So one thing I do want to mention, actually, just because I did just paste that docs link. I have been writing documentation for this sort of thing for our team for my time on this team. And so yeah, if you're looking to set stuff up, right? Set up another virtual machine or set up the proxy, which we'll do later. There is documentation on, like, every exact step that we're going to do, and that we just did today, right? So, for example, this one I just pasted in the chat here. This is what I was reading off of for configuring our Ubuntu VM here. And yeah, just it doesn't look like we have the 2026 repo set up yet, but yeah. Just in case you're needing to in case you're wanting to set stuff up, we do have instructions and stuff.
I just wanted to say something because we're basically at the end. You guys should wish Isaac a late happy birthday. It was his birthday.
Yeah, happy birthday, Isaac.
Happy birthday,
Thank you.
Isaac.
Birthday.
Happy birthday.
To you.
Oh my goodness. It would be a happy birthday if the stupid Linux routing table would just work. I can't with this. I can't with Linux. This is what I get for not having DHCP. Oh my word. I'm setting up a DHCP server. This is ridiculous. I can't do this, guys. I can't. My patience is too thin. Anywho, well, unless there was something else you wanted us to do, Chad. I mean, we might have enough time to. No, not for proxy. That's messy.
It's messy, yeah.
Yeah, well,
Yeah, I mean, we're in a
good.
good spot, though. I think we're in a really good spot.
Yep. No, I think we're good. We accomplished the goals for today, and this is really meant for next week to build upon, the setup that we did today and start the configuration process, next week. So.
Oh, absolutely. Yeah, and also, just real quick, sorry, Axel, but for the people who just set up VMs, feel free to mess around with these machines. I mean, they're VMs. You can't really download resources on it right now, but there's a lot of default tools, and just get used to just Linux. Like, ask questions like, how do I navigate directories? Like, feel free to just kind of mess around with it. I mean, you saw kind of how easy it is to set up a VM. We can get these spun up for you really quick. So if it breaks, just let us know and we can revert it and you'll be good to go. So just get curious, mess around with Linux. We're going to be dabbling with this quite a bit as we get closer to competition.
Absolutely. Isaac,
Axel,
did you get the VPN script I sent you? Did I send that to you?
I did, and I was going to patch that up.
Yeah.
I will. I have family coming over today. I can do work on it tonight, I think.
Thanks. And
yeah.
Cool.
Well, that's all I got.
Yeah, great job, guys. And I would if you guys, like, Isaac said, feel free to dabble and play with your, VMs and throughout the week. If you guys have questions too, I encourage you guys as a team to kind of collaborate on Zulip, ask questions and, work together as a team.
Yeah, as I tell my kids in mock trial, there's no such thing as a stupid question. We're here to help you guys. Well, on that note, I'm going to have to go ahead and get going, gents.
Sounds good.
It was a pleasure. I will see you guys next week.
Yep.
Later, bro.
See ya.
Thanks,
Later, gang.
And we'll see you
Bye.
guys.
Is that everything we have to talk about?
That's it for today.
All right, bro. I'll see you guys next week.
Sounds
See you
good.
next week.
Thank you
See
guys
ya.
for
Yeah.
joining.